Imagine walking alone through a quiet marsh after sunset. The air is cold, the ground is wet, with no streetlights or houses for miles. Then suddenly, a faint blue light appears, hovering just above the mud. It flickers and drifts. For centuries, travelers reported these sightings under names like WillOTheWisp or ignis fatuus. In earlier traditions, they were often described as spirits or ghosts, believed to be supernatural forces leading people away from safe paths. To a traveler in a remote wetland with no visible lantern or campfire nearby, the conclusion was understandable. There was no obvious source of heat, yet the light continued to glow and move in the darkness. The shift toward investigating these lights as a natural phenomenon initiated a search for a physical mechanism that could account for a flame appearing in the middle of a frozen swamp. To find a physical explanation, we have to look beneath the surface of the marsh. A wetland functions as a massive, waterlogged biochemical engine. Organic material, such as dead plants and biological debris, sinks into the waterlogged soil. In this environment, oxygen is scarce, allowing specific microorganisms to break down the matter through anaerobic decay. One result is the production of methane. This highly flammable gas slowly accumulates in the muck before bubbling up. As these gas pockets breach the waterline, they release methane into the atmosphere, saturating the air just above the damp ground. We have identified a massive source of natural fuel, but the presence of gas doesn't account for the ignition. Methane does not ignite on its own at typical nighttime temperatures. It requires an external source of energy, a spark or a flame, to begin burning. Earlier chemical theories suggested that trace amounts of phosphorus gases might provide the trigger by auto-igniting when exposed to oxygen. However, these reactions proved difficult to replicate in a way that matched the specific movement and color of historical sightings. Without a lightning strike or a campfire, a dark, freezing marsh offers no obvious source of the energy required to start a fire. This forced researchers to look closer at the water itself, focusing on the microscopic physics occurring at the moment the gas is released. In 2025, a research team used high-speed imaging to investigate the behavior of methane microbubbles as they move through water. They observed that as these tiny bubbles move and collide, electrical charges become separated at the interface between the gas and the water. Under certain conditions, the electrical field between neighboring bubbles becomes strong enough to produce a tiny discharge across the gap. Researchers called this phenomenon microlightning. This microscopic spark generates enough heat, initiating the non-thermal oxidation of methane, producing a brief visible glow. While this mechanism has only been observed in a laboratory setting, it demonstrates that nature can generate its own internal ignition source without external heat. The physics of moving bubbles creates a microscopic spark, providing the energy needed to light the methane produced by the marsh. If the light is fueled by gas and triggered by microelectricity, we can finally address why it often appears to behave like an intelligent being. Gas release in a wetland is never uniform. Pockets of methane can emerge from different points, and once airborne, they are easily pushed by wind and air currents across the landscape. In total darkness, humans lack visual reference points, which makes judging distance nearly impossible. A light that is simply fading or flickering out can appear to be an object moving rapidly away from the observer. The reported colors, ranging from pale blue to greenish hues, are the result of localized chemical reactions and specific environmental conditions during the oxidation process. The supernatural traits of the WillOTheWisp emerge when the human brain attempts to make sense of erratic gas movement and poor nighttime perception. The journey of the WillOTheWisp shows the transition from a folklore of spirits to an investigation of biological gas and microelectrical physics. The discovery of microlightning reveals that the flickering lights of folklore are a direct product of the microelectrical physics of a living wetland. A faint light appears over the wet, muddy ground, flickers for a moment, and then vanishes into the darkness. The chemistry of the natural world proves that the reality of a living marsh is far more complex than the ghost stories once used to explain it.